I'm going to show this film first. Most of you have seen this, right? I'll probably be referring to it. So it's just kind of making a ground floor of what we're going to be talking about. If I can figure out, there we go. And we'll just watch this. I hope it's loud enough, too.
You want to get an edge on turning back the clock? Just a few pills? Who doesn't? Well, it's no longer science fiction, but science possibility. A potential breakthrough. As I found out firsthand, there may be a way to erase years, at least inside my body. Granted, it's down the road, but some scientists are wondering if a new pill I took might offer a very long life. It may not look like the fountain of youth, but inside this nondescript building, I'm about to become part of an exciting experiment, a kind of guinea pig. Okay. I'm here at the University of Colorado in Denver to meet Dr. Joe McCord, a world-renowned scientist. This is pretty exciting stuff you're finding, huh?
It is. We're very excited about it.
His latest research could very well unravel the mystery of aging itself. And his decades of experiments may have the potential of adding years to people's lives and possibly prevent chronic diseases like cancer, diabetes, and heart disease. It all centers around this small yellow pill, and for me, it begins with a blood test.
It wouldn't be the first time I've given blood for this company.
They want to check my levels of something called T-bars, which is a rough indicator of a person's actual age. T-bars can identify a condition known as oxidative stress, a kind of measure of the wear and tear on our bodies. Oxidative stress, like the rusting of an engine, is not a good thing.
Bad for the body.
Leading to disease.
Leading to disease and leading to malfunction, and importantly, leading to what we call aging. It is a slow progression of increasing oxidative stress. That's the main characteristic biochemically of the aging process.
The problem of aging begins with the very food we eat to give us energy. As our cells burn that food, they also release toxic chemicals. Those chemicals, you may know them as free radicals, react with all the components of our cells, literally bombarding them millions of times per second, damaging all our cells. The result? Oxidative stress. We all have it. The body fights back with a system of defenses. It makes two antioxidant enzymes, catalase and S.O.D, whose job is to gobble up the free radicals before they can harm our cells. But as we get older, some of those toxic radicals overwhelm our enzymes and wreak their havoc. For a long time, scientists thought that antioxidant vitamins like C and E would lower it, but they don't.
It's turned out in just the last 5 years or so, we see that they're not good enough tools. They're not powerful enough.
But this pill, he says, is powerful enough. In fact, many times more powerful.
So, Doctor, how often do I take these?
And so, here I go. With that swallow, I've just become part of a potentially landmark scientific experiment. It's called Protandim, and tests on both mice and humans have already shown that it revs up the manufacture of those good enzymes in our bodies. More enzymes, fewer free radicals to harm us. Whether that will lead to longer life is still unknown. Experiments to see if mice live longer are about to get underway, but it's a tantalizing theory.
Right now, all we know is that this preparation decreases oxidative stress. Oxidative stress is not a disease, just like aging is not in itself a disease, but it's something that accompanies and is attached to many disease processes.
Have you discovered the fountain of youth?
I wouldn't put it that way, but we may have discovered something that will tell us a lot more about how we age, what happens biochemically, and maybe how we can slow it. So you can see the age-related.
Normally, oxidative stress, measured by those T-bars, increases with age. But in Dr. McCord's tests, taking just one pill of Protandim a day reversed that trend for everyone at every age, even for an 80-year-old.
They all are reduced to the level of oxidative stress that one would expect, frankly, in a newborn or a very young child.
Back to the oxidative stress levels of a child? It sounds too good to be with age. But in Dr. McCord's tests, taking just one pill of Protandim a day reversed that trend for everyone at every age, even for an 80-year-old.
They all are reduced to the level of oxidative stress that one would expect, frankly, in a newborn or a very young child.
Back to the oxidative stress levels of a child? It sounds too good to be true. Will Protandim work on me? Or perhaps it turns out there is some other promising evidence that seems to back up Dr. McCord's findings. That evidence comes from mice that have been genetically engineered to produce more catalase, one of the enzymes that Protandim increases. The researcher, Dr. Douglas Wallace of the University of California at Irvine, says it had a remarkable effect.
We found that they lived, in fact, about 20% longer, which is about a fifth of a lifespan.
He believes that with better techniques, human lifespan can eventually be extended too.
We might be able to increase the lifespan of a mammal by 50%. And of course, if that was a human being, then that might be in the order of 130 to 150 years.
The scientific evidence is there. The pieces seem to make sense. The question is, does this translate into something that humans can take advantage of?
So, just what's in this seemingly incredible pill? Well, actually, its roots are very humble. Protandim is a combination of 5 plant ingredients. Some you may know: green tea or turmeric, a spice used in Indian cooking. Others, Withania somnifera and Silybum marianum, are more exotic.
There's a huge human experience with each of these ingredients. They've been used often in traditional medicine in India and China and many other cultures, in some cases centuries and centuries.
And so, ancient Eastern healing and modern Western medicine may soon be working together. High oxidative stress is associated with more than aging. It's been linked to hundreds of illnesses.
It's at the very center of many diseases: liver disease, diabetes, emphysema, asthma. I've studied all of these: strokes, heart attacks, even mental disease. Yes, depression, Alzheimer's disease, depression.
Dr. James Crapo with the National Jewish Medical Center in Denver is also researching Protandim for the company.
Are you saying that this could be a cure-all? You're looking at something that will have a small impact, but an important impact.
We make no claims about curing any disease or preventing any disease. We hope that when enough studies are done, perhaps such claims might be able to be made in the future.
Clinical studies to assess Protandim in both diabetes and heart disease should start in 3 to 4 months. But what about everyone's old nemesis, aging itself? Well, it's all about balance between the good antioxidants and those toxic free radicals.
If we can tip that back, we may reduce some of the bad side effects of aging. Why my skin is different than that of a baby, for example. That's a very obvious part of the aging process.
What was prevent wrinkles?
But you don't want to make false claims.
Sure.
But could it produce wrinkles, right? It's always possible.
But what about my progress? After nearly 2 weeks now, it's time to get my results. Dr. McCord calculates the numbers. The result? My level of oxidative stress has declined dramatically.
45%, that's excellent.
Just look at where I fall on the graph, before and after.
Which, if extrapolated back, is the level you would see in a newborn baby.
Have we turned back the clock? Well, maybe not on the outside, but deep inside within my cells. Yes, indeed.
Would you suggest I keep taking this supplement?
I would. I can't guarantee it's going to extend your life. I can't guarantee it's going to eliminate any diseases or cure any diseases.
But we do know that oxidative stress is part of those disease processes. I don't want to wait until I'm 80 years old to find out that I should have taken it.
The company that makes Protandim says its tests show the pill, made from ingredients used for centuries, is absolutely safe. But because it's being sold as a nutritional supplement and not a drug, Protandim does not need FDA approval for safety. For more, go to our website at abcnews.com.
I'm going to stop it there. Let's see. Okay. I am trying to find out how it, oh, there it is. There's the play. Oh, no. Let me see. Yeah, but I don't want this timer here. I'm not sure why this is doing this now. So it shows this to you. Hopefully it won't time down. Just let me introduce myself briefly. My name is Alan Richards. I have a PhD, okay? She's a doctor. A lot of times that's confusing. I was a research scientist for the state of Texas and the USDA. Then I taught in pharmacy school for 4 years. And then I worked for a biotech company working on HIV studies all over the world and on hepatitis and some other diseases. And then I started working for a Japanese company. And you've all seen these. I helped bring these to the United States. This was a Japanese company, and we licensed it to Listerine. So this was invented, and I got the approvals for the substance that makes the film that dissolves so quickly. And so I've been involved in that for a lot of years. And also, there are other products or ingredients in products that probably you're using if you use cosmetics for lightening and brightening skin, for taking, for reducing wrinkles and things like that. So I've done this, and I've worked and gone to a lot of places where they are talking about dietary supplements. And I always like to start off, hopefully this won't come, oh, okay. Who knows what 20th century philosopher said this? Am I blocking that? Okay. You know what they say, you don't sell the steak, you sell the sizzle? What famous philosopher said that? That was Cosmo Kramer in Seinfeld. And what was happening is he'd start, I'll move over here, he was telling Jerry he's going to start a company, and Jerry says, well, you don't know anything about that. And he says, Jerry, you don't have to know about it. You don't sell the steak, you sell the sizzle. And that's a way a lot of the dietary supplements, not all, are actually sold and marketed. I was reading a Parade magazine, and I saw this thing on the back page, and it said, increase your cognitive function, increase your memory, especially as you get older. It said it was invented by an Israeli scientist when he came over here and was working at Duke University, one of the premier medical centers in the world. What else did it say? Oh, it said all these great things. So I was reading it, I said, I gotta get this stuff. I need this stuff. And as I read, it was FDA approved, and it had a claim, a health claim you could use. And so I was so jazzed about this, and then I read the fine print at the bottom and said, wait a second, this is the same stuff I'm working on for this other company. It's been around for 50 years. Well, the guy that invented it, well, he just told this company that you need to put these two things together, but they've already been out there. It wasn't FDA approved, it's allowed for use, but it's not approved. And the claim that you can make, the health claim that they said, now they didn't tell what the health claim was, just that there was a health claim. The health claim is, there is insufficient evidence to say that this does what the manufacturers say it is. It's called, it's a health claim that the FDA will give you, where you actually have to say that actually there's really not very strong data that supports the claim. It's called a qualified health claim. It's on, you can get it on olive oil too. It'll say, many studies have shown that there is some benefit, but many more have shown that there is no benefit of using olive oil. But what do people do? Let's go out and get some olive oil because it'll be much better for us. So you just have to watch out for the sizzle, and we're going to talk about that. First of all, just quickly, what is a drug? Because you were talking about that earlier, about people making claims, a substance intended for use in the diagnosis, cure, mitigation, treatment, or prevention of a disease. And that's a little bit of a problem when you say prevention of a disease. That's what McCord said himself. And that's because when you look at dietary supplements, look how big that definition is. It talks about it's something that's supposed to be a dietary ingredient that gives you nutritional value. But down here, some dietary supplements can ensure that you get adequate dietary intake of essential nutrients like vitamins and stuff. But then it says others may help you reduce the risk of a disease. And that's the claim that you can get both here and in Europe for dietary supplements. I deal with the FDA and with the EFSA, it's called, European Food Safety Authority. And so you can get a reduced risk. What's the difference between prevention and a reduced risk? What it is dietary supplements are considered foods. And foods, if you eat the right foods, you should be able to lower your risk of getting disease, but isn't that kind of preventing it? So there's a real thin line there that people walk for that. Rats. Okay, now let's go through these just quickly. I know probably a lot of you already have heard this and preach in the choir. Free radicals he talks about, that's still used in a lot of places. However, most people now are using reactive oxygen species. It's another word for them. Also, I've always used, when I've been doing research, oxygen radicals, because all of these that they've talked about so far include oxygen, and that's the active portion of it. There are some other ones that are very important for a lot of the cardiac diseases and things, and those are reactive nitrogen species, and we'll talk about those. However, those also have oxygen in them, most all of them. And I'll talk about what those are and how they act. So, what these are these are substances that are continually produced by our body that are just highly reactive. It's like pouring acid on wood or acid on certain metals and stuff. They're just highly reactive. I mean, you can talk about free radicals being substances or oxygen substances that have an unpaired electron in their outermost shell and all of that. But the point is they're just highly reactive chemicals or substances. An antioxidant is something that will just neutralize it. A lot of times they'll use the term detoxify. I don't like to use that because then people start thinking, oh, where's he going to put that stuff to detoxify me? Is he going to go in with the coffee and up the other end and stuff? I mean, I just call it neutralizing. It's just like the high school acid base. Pour this on this, you know, it burns the paper. Pour this on this, it burns the paper. You mix them together, and it's completely neutralized. And that's what you're really trying to do. You're trying to neutralize the activity of this. And the only reason these things have activity is because they have chemical energy. They have chemical energy that they can use to rob and to change things. And we'll mention some of those. So then we talk about this general term, oxidative stress. So the oxidative stress is just an imbalance between the amount of these and the amount of these you have, regardless of where they come from. Some of these can be produced because of your environment, so they're exogenous. Most are endogenous. We produce our own, and we'll talk about this. So it's just the balance in between. And as you get older, the scale goes in the wrong direction. You're producing more bad things than you're getting rid of, and we'll... So the point of this is that these free radicals or oxygen radicals, there's a lot of different types, and we're producing them in our body all the time. So you can't get away from it. If you exercise, you burn more oxygen, and what will happen is you'll produce a higher percentage of oxygen radicals. And I'll talk about that. But what the problem is here is that because of their high energy and their reactivity, they can react with normal substances in our body that we need, and it can change them so they don't function properly. They may not function at all, or they may just function at half what they're supposed to be doing for us. Now, the damage by these free radicals, lipid peroxidation, all of your cells are made of lipids, and they have proteins stuck in them. And one of the most damaging things that these free radicals do is to oxidize lipids, and it decreases the cell membrane function. They're more fragile. They may not hold the proteins as well as they're supposed to. So therefore, then the protein can't do its job, because there's a lot of proteins that are on the outside stuck there. There's a lot that are on the inside, but there's a lot that go through the membrane that are used to transport or send signals in and out. And so if those are changed, they just won't work very well anymore. DNA, mutagenesis and plastogenesis, that's just, the second one is just another kind of mutagenicity. They can mutate. They can mutate at the base or at the sugars. DNA, deoxyribonucleic acid, it can modify or mutate, really physically mutate either one. And that can cause cancer, or it can just cause malfunction of your DNA. It doesn't replicate like it's supposed to, or it doesn't produce the right kind of proteins. And then also just proteins themselves, they can be reactive with free radicals, and this will cause dysfunction. So if it's an enzyme, it will cause that enzyme not to work well or work at all. If it's a structural, it may cause it not to be put in the right structure in the membrane where it's supposed to be and have a function. The membrane may be fine, but because it's changed the structure, it may not be able to get in where it's supposed to be. And then finally, one of the most important things nowadays, aggregation. Alzheimer's, a lot of the diseases that are neurologic diseases are caused by the aggregation of amyloid. Beta amyloid is a protein, and that's what causes AIDS, causes mad cow disease, and other things like this. And those particles are caused because they become oxidized and then they start sticking to one another. This is really simplified, okay? So, now, here's the cross-section of a cell. He showed a picture of it, and it showed that the oxygen radicals are being produced in the mitochondria. The mitochondria produce what? They produce most of the ATP. When I was just starting in graduate school, ATP, I mean, they just discovered it a few years before. Okay, so that's the energy currency in our cells. And so as they do that, I'll talk about that in a second, about what happens. But so when these are produced, they can react with all of these other substances, the cell wall, these different kinds of things, and can cause them to misfunction. Oh, but, so if these things are being produced, this is the point I want to make. You saw the T-bars? That was measuring the blood. All of those things, it measures something called malonyl dialdehyde. And that is the end product of free radicals. So you can measure that in the blood, and it's a, what do you call it? A test where you use a color dye, and it'll show you how much is there. It's all being produced here, but where is it showing up at? In the blood. Okay? Where do you want to stop it? And we'll talk about that in a second. Okay, so here we are. Our bodies as a whole, or our cells, are like a car. When you buy a new car out there, my first new car in 20 years, when you buy a car and they test it, it is going to be, the engine is going to be as efficient as it's ever been. Okay? Sometimes you can rebuild it, but most of the time it'll go down. And as it becomes, what do cars need? Fuel. Okay, now, he said that this oxidative stress starts with the very what? Food that we eat. Well, he left out half the equation. What's the other thing you got to have to burn anything? At least on our, you got to have oxygen. That's what oxygen radicals, reactive oxygen species. Okay? So you have to have this to burn it. And if you burn it efficiently, what do you get? You get CO2 and you get water. That's what it's supposed to be. If it's 100%. But if it's not 100% efficient, what do you get? Exhaust is not bad. Exhaust is CO2 and water. But if it's not burning completely, then what do you get? What do we call it?
Pollutants.
What? Pollutants. Pollution. How are you doing? We get pollution. And so it's not the exhaust, it's the pollution. We do this in our cells also. If we burn our fuel perfectly, you know what you get? CO2 and water. That's what it's supposed to be. But unfortunately, we're not efficient. And just like your car, as it gets older, it gets less efficient. In addition, to take out the pollutants, what does a car have? Catalytic converter. Okay? It's supposed to remove it. Now, catalytic converter is really physical. So if it gets, over time, it will get less efficient too. So you have two problems. The engine's producing more pollution, free radicals, and your catalytic converter is getting less effective at taking care of them. And that's why you get this over time. Now, the exact proportions, I don't know. I've read and I've never seen about that. However, what we have to remember is that, unlike a catalytic converter, we have innate antioxidative systems that can regenerate themselves. But we do know that they become less efficient over time. And therefore, goes the other way. The balance goes the other way. So, an antioxidative myth. Where are these oxygen radicals being produced? In the cell. Where do you take these antioxidants that they sell? In the mouth. I've gone to some of the biggest companies that produce these. I say, well, how much gets in the blood? Well, I've never looked at that. Well, wait a second, how much gets in the cell? I've never looked at that. Well, what have you done? The test for antioxidation of these chemicals is just a chemical test. You put it in a test tube, you put in something that generates free radicals, and then you put in your blueberries or acai juice or something like this, and see how much of that is neutralized, and that gives you an ORAC number. There's Trelox, there's ORAC, there's 4 or 5 different chemical methods of measuring that, but that's just in a test tube. That's just in a test tube. So the question is, well, what does it do in the body? That's really the question, isn't it? And where does it do it? Let's see if I can get this. I don't think it mentions this in this one. Stoichiometric chemistry. That's Na plus Cl makes NaCl. Okay, that's just the chemical way. A chemical antioxidant neutralizes one oxygen radical. 1 to 1. That's all it can do. Okay, well, we produce a lot of oxygen radicals. Let me show you this. Okay, so how is it measured? It's a chemical test. Do they get into the blood? Do antioxidants get into the cells, where it's the production? What we have is the example in the film of superoxide dismutase. Superoxide dismutase takes superoxide, one of those free radicals that I showed you, and that's the first one that's produced usually. It takes that and it can neutralize it. However, one molecule of superoxide dismutase can neutralize up to 1 million oxygen radical molecules every second. So, taking antioxidants is kind of like going to a fire with a Dixie cup. And I'll show you why. Let's see. Oh, and other antioxidant systems are the same way. What do these numbers represent? This is 1 sextillion, 1 times 10 to the 21st. Oh, by the way, these are not my numbers. Okay, I've gotten, this is from BBC Science, the others from some scientists at Life Vantage. 7 sextillion, you know what that is? That's the number of grains of sand of all the beaches and deserts in the world. Remember that as a kid? 5,600. 1, 2, okay? Now just think of that, Sahara, all those. That's what they're saying the number is. University of Hawaii has another, but it's similar. I mean, it's just astronomical. Okay, what's, if I'm hitting the right one. What's this number? Now this is 41 times larger, and I've seen it as 1.5, half that. So this is about 40 times larger than that. Does anybody know what that is? That is the number of free radicals that you produce in your body every day. Now, probably if you're younger, Mason, you may be producing maybe 150 sextillion. Okay, so it's older, maybe producing 450 sextillion. But it's 41 times greater than all the sand and all the beaches and deserts in the world. Okay? Taking an antioxidant, how many oranges does that take? Okay, to get enough vitamin C. You can mainline it, and you can't get enough because it would neutralize the stuff in the blood, and then what happens to it? It's gone. It's a one-shot, 1-to-1. So it's gone. And it's not even occurring here. I read an article, and I've been trying to find it, because I'm sure I was right about this. This one guy said is, an oxygen radical being produced in those mitochondria, there's an opportunity for those to react with up to 200 molecules, good molecules in your body before it gets to ground state or loses all its energy. It can pass to one, and then it passes some of the energy on, and then that one will pass it on, and that will pass it on. Here it's malonyl dialdehyde. That's way down the list. That's a substance that you get from the cell membranes, from the lipids, that ends up in the blood that's been oxidized. Okay? So where do you want to stop it? Okay, so here's my analogy. Don't have time for the long version. Annie Mayberry. Okay? A quarter on the desk. Opie's sweeping. Barney's in the back. The sheriff's not there. Next scene. Sheriff comes back in. Barney comes out of the back. Opie's gone. The quarter's gone. What does Barney say? Every third episode. This is the line. Andy. He goes, Barney, did you see where the quarter went? No, I didn't. The only one that's been around is Opie. 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 Good heavens. You're going to do something right now. Well, Barney, should we find out? No, you got to do it now. It's quarters. Then it's fast women, fast cars, banks. Andy, you've got to what? Come on, help me out. What do you got to do? You got to nip it. You got to nip it in the bud, Andy. Okay, where do you want to nip this? You want to nip it here after it theoretically could have already caused 200 physical mutations, not in the sense of genetic. Well, it is the same sense of genetic, but most of these things don't replicate themselves. So, do you want to do it here, or you want to do it there? So, where do you want to nip it? In the bud. Other than not listening to anything I've been saying. You want to nip it, in the bud, okay? Now, in fairness though, our innate systems are taking care of most of this. And when you're a baby up to about 20 years of age, it's in equilibrium. And then you start to not be able to take care of it as fast because your innate systems won't do it, and you're probably churning out a little more. Okay, health benefits of antioxidants. This is interesting. So, for 20 years, the USDA, who's responsible for our food and nutrition, they had a list of the relative amount of antioxidant activities. Dark chocolate, red wine, white wine, this, peanuts, a big long list. 2 or 3 years ago, I think it's probably about 3 years ago now in March, it disappeared. They just stopped putting it in there. And what they said was, those values have never, ever, never been shown to have any physiologic benefit. Nobody can do that. You can't say anything. The FDA and EFSA, this is the European, disallow food labels to claim or imply any benefit from antioxidants. Bless our mom, every Christmas. Alan, I've got the 7-Up with the, is it cranberry or cranberry juice? And it says antioxidants. You know what they add? They throw in some chemical vitamin C. That's an antioxidant. Has nothing to do with cranberries. They're probably artificial cranberry flavors. Okay? So there's a lot of things that you can say about this. But what's interesting about it is that EFSA, the Europeans, you can't even put the word on a bottle that has antioxidants in it. You know why? Because they believe that 99.99% of the consumers will assume that because it has an antioxidant, it has some health benefit. It's never been shown. Palm went over there, wanted some health claims. They said, where's the beef? Where's the steak? You know, you got really good commercials, but have you ever shown that it actually had some benefit? When you take that stuff, I saw one study, so let's say we're up here where I am. What will happen is if you take one of those super juices, this thing will go down for about an hour and a half. Okay, well, here's another $40. It'll go down, but it'll come right back up. Because they're being neutralized, just like the oxidants are being neutralized, they're being neutralized too. Now, within our body, vitamin C and vitamin E have a turnover system, like with glutathione too, so they can be regenerated. Okay, so what makes Protandim different? Okay, Protandim is an NRF2 activator. That stands for nuclear factor erythroid-derived 2 hyphen like 2. Got no idea where they came up with that. Okay, I dealt with some of these for years, and somebody thought that this was a good idea. But NRF2 is a good sounding, and that's what most of these meetings now are revolving around for Life Vantage. They're revolving around NRF2. But you got to get there. You got to understand why this is important. Now, so what is NRF2? What's it called?
It's an enzyme. Or it activates the
enzyme. It is a transcription factor. We have dozens of these. And what a transcription factor does is this. So this says keep 1. It is bound to NRF2 in the normal state of a cell, and it's bound close to a receptor. And that receptor can be for something in Protandim. We don't know what it is in Protandim. I mean, Protandim's full of what? 5 secrets and kernel secrets spices. Is it everything? I mean, when they take the whole plant and crush it up, there may be only 1 chemical out of 10,000 that are in there that actually do this. You know, we don't think about it that way, but that's why we got into pharmaceutics too. You know, the pharmaceutical industry is, well, let's isolate what that is. They just approved an NRF2 activator for what? Multiple sclerosis. Do you know what the #1 researcher from the Netherlands said? He says, you know, in my experiment, I tried this yellow pill from America called Protandim, and it actually worked better than my pharmaceutical agent that they just spent like maybe $40 million getting approved for multiple sclerosis. These are some test systems and stuff. But anyway, so it's a transcription factor, and what that means is, but we digress. When something binds a receptor here, it sends a signal and it changes the electrical structure of this, and it releases NRF2, and this NRF2 goes into the nucleus. And then what does it do? Huh? The what?
Kills bad stuff.
No. It starts the good stuff.
It parties.
Yeah, party. NRF2 transcription factor that regulates gene expression. Okay, it regulates gene expression, and it regulates probably greater than 500 what they used to call survival genes. Now they're calling ARE genes, which means antioxidant responsive element. And what's interesting about that is they have found out that that's only part of it. Because when we talk about antioxidants, we're kind of thinking that's what Protandim does. But Protandim is this NRF2 activator, so I'll just show you a couple other things that will do it. Now, this isn't unusual. I work with interferon. And if you take interferon or give it, it can stimulate 1,000. So a lot of the things that we take into our body will turn on genes. What NRF2 does is once it's changed, it goes to about 500 sites generally speaking, in the nucleus where we have our genes. It sticks to something called a promoter sequence, and it turns on that gene. Now, we have proteins, we have carbohydrates, we have fats, we have DNA in our bodies, and they're all produced by genes. What do genes produce? Genes only produce proteins. They don't produce lipids, they don't produce the carbohydrates, they don't produce anything. They produce proteins only, and those proteins are what produces the lipids that are in the cells, and the other DNA, and other things like this. Okay? So that's all they're producing. So we're gonna start stimulating about 500. Now, what is interesting is in one of the studies that they had done, they looked at the stimulation. And not only will you upregulate, means to stimulate, you can upregulate a gene, but you can also downregulate a gene. Okay? Your mother telling you, you just ate, don't go in swimming? That's true. That's not a wives' tale. Now the question is, what's the percent of people that are going to have cramp? but actually it's quite a high, because what happens is when you eat, the body shunts most of the blood to the stomach for digestive purposes and away from your large muscles, your striated muscles. And so if you overuse those, builds up lactic acid and it causes you to have cramps. Builds up CO2. Can't get rid of it fast enough. The same thing with this. There may be some times where you want to increase one gene, but you want to decrease another because you need that energy. Those ATPs that you're producing, they need to be used for a particular purpose, like survival. Survival. So, some of the things, what makes Protandim different? Again, the types of genes. The first type, as we know the best, are antioxidation genes. So these are the common ones like catalase, superoxide dismutase. Those are the two that he talked about in the film, but there's dozens of others. How many have heard of glutathione? Okay, glutathione has to be produced from somewhere. Okay, and it's produced in your body, and then it has to be used to break down hydrogen peroxide. Did you know hydrogen peroxide is one of the active oxygen radicals that we have in our body? You remember when you used to pour the oxygen and it fizz up? Yeah. 20 years ago they said, do not put oxygen peroxide on there anymore. It's killing more of your cells than probably infection will, because it's so highly reactive. You just don't do that anymore. Now I do it just because it looks cool, because it foams. Okay, but you're not supposed to. Go on to Mayo Clinic or something like this. There's many different enzymes that are produced that are to neutralize these oxygen radicals. And there's all sorts of different oxygen radicals, like I mentioned. The next thing that they found out is it stimulates some of the DNA that is responsible for producing enzymes, proteins, that repair the lipids that have been damaged because of oxidative stress, the proteins that have been damaged, the DNA that's been damaged. So every time you have a mutation in your DNA, there's a little train that comes along and tries to repair that. And probably it looks like one of those little trains that you used to have, and you see them on the railroad, probably goes right down the DNA. It senses there's something wrong, goes down the DNA, and then one thing comes in, pulls out the wrong thing, senses what the right thing should be, and puts it in. Okay? So DNA, proteins, and lipids repair. Now see, we don't think about that as antioxidation, but what it is survival. And it's to keep ourselves healthy. And then detoxification. Now this is detoxification as usually we think about it. We have organic and metals that are exogenous, that we get exposed to. Also, sometimes we produce them ourselves in certain instances. And what happens is there are proteins that are produced that will find that metal, and it sticks, and the metal will float around until it binds to something bad and causes trouble. So what it will do is it will grab another protein like albumin that we have tons of, and it'll stick it on the metal. And as soon as that happens, the body will recognize that that needs to go. And so it'll be excreted usually in the urine. The kidneys will take it out because it's of a certain size. So it helps to detoxify those things. Again, we don't think about that as in terms of oxidative stress. However, most of these things have occurred, a lot of these situations, because of oxidation of metals and other proteins that contain metal. Is there anything else there? And then anti-inflammatory. Now we know, and they've been talking about how it can help, Protandim can help inflammatory situations. And this is one of the reasons. And there's specific genes that are kind of outside the antioxidation that we normally think of and we see on these things. It reduces something called, this is, it's nuclear factor B cell, kappa B cell. And what the situation with that is, it's interesting because that's the same thing. It's a translation factor, like NRF2, NRF2. It's sitting out there too, waiting to be stimulated. But what stimulates it is inflammation signals, proteins that are produced during inflammation, and so it stimulates the inflammation to go on. And Protandim, or an NRF2 activator, will downregulate the production of this NF-kappa B. So it's really getting confusing. Now, but what's nice about it is it's all very consistent. It's very consistent. That's what got me into this, because I read the other papers. I read all of the Protandim papers, but I read other papers. I have this paper somewhere in my file, and what this guy says, this is like 10 years ago, he says, what the world needs is a good NRF2 activator. Years ago. And this guy's studying, oh, I don't know, some goofy disease somewhere. But he knew it was caused by oxidative stress and inflammation. He says, if we only had a good NRF2 activator. Now there are hundreds of articles on NRF2 activators. Actually, I have one here. He has the diseases associated with it. He has about 30 different diseases and maybe 100 citations, but those citations are actually reviews of each one of hundreds of papers that are talking about it. So there's a lot of work going on in this, and we're the first ones to have a product, and it doesn't have to be done by prescription. You know, if you went into a doctor, would he say, yeah, I don't have anything for you, but you know what? I can prescribe you this really good multiple sclerosis thing to do it. It's not going to happen. It's not going to happen. Okay. Now, so where do you go? Where do you go to find your information? Well, you go to peer-reviewed studies. And peer review means reviewed by subject experts or peers of the author who's made this. I'm just going to go through and do these to... Oh, rats. Okay. Experts, they look for mistakes, methods, results, conclusions. I've had that done. And they make these things anonymously. And the best part is when you, and they usually use red pen because they know it really chaps you off. But the best part is sometimes you know who's making the comment. Because he made the same snide comment when you present the paper on it, like 6 months before. You know, so you can tell that reviewer, that S.O.D. So they can suggest changes for the studies. They may recommend article not be published at all. The purpose of peer review is to ensure that the highest quality are published, highest quality studies. Now, the problem is people cheated. You know, they made up data and stuff like this. One of the most famous cancer studies, one of the really basic one, the guy used the El Marco on a mouse. He was grafting in on a white mouse a black thing. It wasn't working, he just used the El Marco on it. And it went on for quite a while but you have to be complete enough in your description that somebody else can repeat it. And nobody could repeat it. So then they start going back and say, well, show us your data. Now, how do you know if a journal is peer-reviewed? You have to go to the journal and look in the front and it says instructions to authors. And it'll say, this is peer-reviewed. It'll go out to 2 reviewers. If they disagree, we send it to a 3rd. It used to be 3 all the time, but it's just so expensive and trying to find reviewers, it's hard to do. Or, one thing you can do, you guys all know about this PubMed. It's U.S. National Library of Medicine, National Institutes of Health, PubMed. They reference about 10,000 journals that are peer-reviewed. So these articles are as high a quality as you can get. The one that on that super juice that I read, where it causes this to go down, it was published in a journal that said, this journal is for the purpose of publishing information and data on dietary supplements that couldn't get published in peer-reviewed journals, but we think it may be worthy of note. That's the rationale. There are journals, India, Pakistan, that you can send in with the right amount of money and get them published. Okay, so if you go there, here's what it looks like. Have you all done that?
Yes.
Okay, yeah, sorry. Now, what is interesting is if you go and you put oxidative stress today, this morning or last night, it was 147,162. If you go there in 5 to 7 days, there'll be about 250 more articles. You think this is an important subject for people? It's the #1 topic in scientific discovery now in medicine and biology. Okay, and then you can put in oxidative stress and some disease, yes, totally uncontrollable. Okay, so now the 14 peer-reviewed studies, I was just going to review very quickly. Like I said, usually I found out this one doesn't have a remote control. The first two, in 05 and 08, when they made that film, John Quinones, they hadn't published anything. I don't know if you knew that. Nothing had been published yet. So that data that you saw was in the publications, but it hadn't been published yet or peer-reviewed. So it showed that oxidative stress could be reduced 40 to 70%. But what was interesting, and more important, is that they showed that the amount of superoxide dismutase and catalase went up. Meaning that Protandim, not knowing about NRF2 activators at the time, was causing this activity, and they were producing it where? In the bud. That's what you meant to say. In the bud. In the bud. Okay, you're going to nip it in the bud. Now, I always love the second one. It says upregulates glutathione 300%. Glutathione is very important. Well, now we know that that is one of the other things that NRF2 does. It stimulates not just the production of these enzymes that are directly antioxidative, but it produces some of the substances like glutathione that are used over and over. And glutathione is regenerated. Vitamin E is regenerated with vitamin C. But there has to be enzymes to do that. Okay, the LSU study, there are 3 of them. So in practical and potent approach for cancer prevention, I had 26 frozen off. I started taking Protandim. The next time I went back, there were like 4, I think. I mean, we've got myeloma filthy in our family, okay? And precancers and stuff. I take it every day, just for that reason. And I'm too dumb to put on stuff before I go out in the sun. So, anyway, but practical and potent, it reduced the incidence of cancer by 33%. Why that is important is, if I'm not forgetting, because I haven't reviewed these in a while, the study, it was 100% effective. I mean, no, I'm sorry, let me go back. When you implanted the tumors, it killed 100% of the animals. Now that isn't what happens to us. I mean, we have these genes that we now know for ovarian and cancer that increase your risk. What we're talking about from 2% to 5, 6, 7, 8%. Okay, we're talking about this is 100%, and it reduced it by 33. I mean, that's remarkable. If most cancer treatments got 33%, they'd be dancing in the streets. It just doesn't happen that much. It's getting better. The Virginia Commonwealth, pre-treatment with Protandim, strong cardioprotective effect. Okay, it's not supposed to prevent, as I say, it's supposed to reduce the risk. Well, this reduced the risk quite effectively. Was there anything? Oh, and the other thing is fibrosis is that thing about the aggregation of what? Not the clots, but the plaque and stuff is aggregation of protein that causes this fibrosis, scarring and stuff. That's one of the things that showed that one of the genes now that they know that helps reduce the aggregation. Okay, Ohio State, Protandim inhibits blockage of vein grafts. This is kind of interesting, but it's very specific, and there's other ways that they get around that anyway. But it's scientifically, it's a really interesting study. CU, Protandim significantly modulates pathways for antioxidant enzymes. That's the one where they looked at all the different upregulation and downregulation and saw that some NRF2 is upregulated, some downregulated. They did a 7-day study. I'm not sure who talked them into this, but did a 7-day study. These were alcoholics, and recovering alcoholics have high permeability in their alveoli of the lungs, and so they tried it for 7 days. But nothing happens for for a couple weeks. Well, a couple weeks and stuff like this. But I'm not sure why that was done. It was just kind of a goofy study, and it's like, they must have had some subjects, and they said, let's try it. We got these people for 7 days, and then they're gone or something. Okay, CSU had some really interesting ones, because see, do you recognize some of these things? That's glutathione reductase. those are those enzymes, the antioxidant enzymes, that it's been shown that NRF2 upregulates, speeds up. So what they did is, do you know what cardiac means heart? Endothelial, those are the cells that line the blood vessels and line the chambers of the heart. Okay? Cardiomyocytes are the actual muscle cells in the heart. They're really neat looking. They beat on their own. Okay? And so what happens is they gave pre-treatment to these cells. So this is in cell culture, like a petri dish, the things have grown out. And they're looking at these. So they give Protandim treatment, and it resulted in, number one, it showed that NRF ended up in the nucleus. This is way before most people were preaching about NRF2. So they saw, I mean, they knew that probably this is what was happening, but they showed that it actually went to the nucleus, so it's showing that the mechanism is correct. Then it says significant increase in the expression of all of those antioxidants, enzymes, reduced H2O2, hydrogen peroxide cell death, from 34 to 6%. I've run these studies before, not with these particular cells, but what you do is you put cells and you put hydrogen peroxide on them, and it kills it, because it's an oxidant. It's quite a significant oxidant in our bodies. So what happens is, when they did this, they had it so a third of them died. When you pre-treated with Protandim, it reduced it from 34 to 6%. I mean, that's pretty good cardioprotectivity. Okay? It's just showing that the cells are protected. Somehow, it signals the cells, and the cells can then protect themselves from an oxidative challenge. The third one was inhibition of NRF2 reduced some beneficial effects. So they could block this NRF2, and all of a sudden the good things went away. This was a real big deal a few years ago, because nobody really knew what was happening. So Protandim treatment of cardiomyocytes resulted in similar benefits. The NRF2 response with Protandim was greater than when they used natural oxidants. If you put H2O2 in low concentrations on cells, those cells will respond in an NRF2 fashion, but nowhere near the response that you get with Protandim. Okay, nowhere near it. Okay, and then the CU treatment with Protandim, as well as other stuff, reduced in vivo high altitude induced cerebral vascular leakage. A lot of the headaches when you have acute altitude sickness is that water leaves the blood vessels and goes into the tissues, and so it gives you kind of a migraine headache. Okay, that's where this headache comes from. Now what's interesting is that's probably what they were trying to do in that 7-day alcoholic study, to try to reduce the leakage, because then their tidal volume and the amount of oxygen that they can exchange and CO2 is reduced quite a bit. So this shows that it works. It says in vitro, it attenuated hypoxia-induced H2O2 production in brain endothelial cells. So anyway, those are the studies. I don't know, there's a lot of additional studies going on. We don't have time. Anti-aging, I know you've talked about this before. There's Protandim from the inside out, taking the pill. And then there is also, does anybody have the lotion? Well, yeah. So I use it on my ears, on my face. The organ or the area of your body that has the most oxidative stress is exposed skin, because UV light, ionizing radiation, and pollutants will cause in your skin the production of oxygen radicals, and also those other toxins, like metal toxins and other things like that. So that should be used. This is what this was showing here. So that UV, this is from other work that I've done with other products that are the company's products. But it showed that you can do this. It's really nice on the skin because you can get it in. It'll go in the skin. An antioxidant, a direct antioxidant like vitamin C, or a stabilized vitamin C, will be effective. You can't put vitamin C in a cosmetic because there's too many other chemicals, and vitamin C is highly reactive itself. Okay? So it'll break down. It'll discolor, break down. So our company and others have stabilized vitamin C's, but when it goes on the skin, natural enzymes in your body break it apart so it becomes active. Okay? Well, here you don't have to do this. The interesting thing about this, so here's, have you seen that picture? This is quite an old picture. I don't even know if there's a newer one. It decreased wrinkles 45%, but the important thing again is that it increased S.O.D. They only check for S.O.D. expression. It increased the expression. That means that the lotion, true science, is getting in the skin, through the epidermis, into the cells that can produce superoxide dismutase, so it can help at the site to reduce the oxidative stress that's on your skin constantly. Okay? So, I mean, this is, if it did this, there's a lot of things that did this. I was just talking to my, who was there today? I was talking, oh, Mandy. You know those opalescent things? You know how they work? It's crushed opal or mica. You put it on and it fills your, your lines and wrinkles. The reason we can see the lines and wrinkles so much is because of the shadows. With the opalescent, it collects light from all the angles, and so it doesn't allow shadows at all. You could shine a real direct light on it, but it would still cover most of the wrinkles because you can't see any shadow, and then plus it fills up a little bit. Other substances, what do? You rub it on, it just draws water. And the water makes it puff up. I got no wrinkles. Use not that, use fluffy. So what was good about this is it increased S.O.D. expression, meaning that it's acting the same way as it does in the body on the skin. And like I said, every time I go out bike riding and stuff, I get, because of the way the gloves are, I haven't done it in a bit, this will become very red, and I'll get these flaky things, I'll scratch it, some of them will bleed just a little bit. Put that on 2 days, they're gone. They're just gone. It's a miracle. It's a miracle. I can see. Now, what you have to realize is it can't do everything. I lost some nerve in my sciatica. That hasn't come back. Okay? A lot of things it can't do. But things like inflammation, sometimes if you can't bend your finger, let's say, and I couldn't bend this one. It was this one. For several years, that's as much as I could bend it, and I started taking it, and all of a sudden I could bend it. Some of the inflammation causes that there's water there, there's edema, and there's hurt, so you don't want to bend it, and you can't bend it because it's just full up with water. Okay? So if you take that down, if that's the case, then you'll get that use back. If you've lost bone in rheumatoid arthritis and something, or the synovial joint or something is worn down, it's a possibility that it could build some of it back up. Just all depends on your own body. But it should be very effective in helping reduce the oxidative stress and other stressors that are not oxidative, like toxic stress that we have every day in our bodies. And I think you guys are done. Okay? Yeah. So if you have any questions, if you don't, get out of here quick. If you do.
My brother in January took some Protandim, and his gums were like really bad, and his teeth were really bad, and he took it. And I said, try this, just because just learning about the product. And about a week later, he said, Scott, this stuff is killing me. I said, my teeth is really hurting, and because of I think it's this what I'm taking. I said, I don't know what's happening. And so somebody said, and maybe you could help. They said that what's probably happening is that the gums was dead and they were coming alive again, or something. I don't know what.
Well, no, I don't know about that. Here's what I can tell you. I started taking this 4 months later. I'd been to the dentist, the same one for several years, but every checkup, my gums were getting worse. When they stick that needle, they stick the probe up, and they said, oh my gosh, your gums are bleeding. He says, you get another step here, you'll see what'll bleed. Well, it hurts. That's not. So what happened was they wanted to put antibiotics there, and they said it's not a long-term cure, but it'll slow down. Next time I went back, that's what they were going to do. If it was the same or worse, it was much better. I'm telling a guy, actually my upline Ron Pierce, at the at a meeting, and I mentioned it to him, and he said, "That just happened to me the other day." And then some other guy was eavesdropping, and he said, "Yeah, my dental hygienist and dentist said the same thing." In Colorado, Denver area, probably every dentist, a high percentage of the dentists are encouraging that. It could have been that what was starting is it was causing an inflammatory process to start that might have been suppressed for whatever reason. It could have been suppressed. And so, you know, do you work through that and see if it really is getting worse or is it getting better? You know, I mean, and sometimes you got to hurt to feel better. So I can't, I'm not an MD, not a doctor, I don't know, you know, but it's kind of funny. Now, I've had people, 2 women, interestingly, and again, nothing, I'm just saying, very obese, in Amarillo, Texas, where there's a nuclear plant, and there are breezes that come holding huge amounts of mold and spores that come from New Mexico, because it's in between, and New Mexico people blow and the Oklahoma people suck. So Amarillo's right in the middle, okay? Well, that's just what I've been told. That's what I've been told. Okay? So, but what happened was, is both of them said they got some sort of, what would you call it? Just not welts, but little bumps. They stop. You know, some people will react to some of those things. Because again, there's thousands of things in there. Don't you love the commercials? You're dying, so take this thing. But if you're allergic to anything, don't take it. Well, how would I know? I've never even heard of the drug before. If you're allergic to anything in the drug, don't.
That's true.
Yeah, well, I won't take it anymore. So you never know. I mean, you know, people would like to say, "Oh no, I've never heard of a bad response or something." I mean, I've heard of some. They haven't been bad responses. Then you just stop. It goes away. But it could have been doing them some good.
That's what I was thinking. Because
it could
stop and it really stopped hurting.
But I don't have to do it either. Yeah.
Is there any good to vitamin C, D, and E other than antioxidants? Because the doctors test your vitamin D levels.
Well,
and
see,
stuff like that.
Yeah, but they're part of the natural system too. So there's something good for that. But the question is, the Institute of Medicine said about 2.5 years ago now, I should write these things down so I know exactly where, they said, except in extreme instances, there is absolutely no reason for an American to take vitamins, minerals, or, unless you have a specific tested deficiency, or vitamin supplements.
Okay.
There's no reason for it. Because nothing's been shown to be that good. Okay. Now, in the first study, I think it's the first study or the second study, what they showed, do you remember? The people that were taking the vitamin C and E supplements did worse. They did worse. And because some of those can become pro-oxidants. Metals can become pro-oxidants. You need metals to do things. Like superoxide dismutase, there is a, it's iron and copper. And so superoxide dismutase has a molecule of iron and copper, and that helps it function. That's the stuff that's found in the cytoplasm of the cell. Okay? The one that's found in the mitochondria is Mn. What's Mn? Come on, no, not Mg, magnesium, manganese. Yeah, manganese. Yeah, so that's found there, and it's found in really high concentration in the mitochondria itself. And remember, it said that one of the things that it did, I didn't bring that out, is that it helps to regenerate and replenish mitochondria. One interesting thing, too, is I think the last word on those lists of all the things it did was autophagy. Does anybody know what that is? Okay. Autophagy is every one of your cells regenerates. We all know that in 180 days, your cells, your red cells all change over. Well, every one of your cells is undergoing that. And what happens is, I was just very peripherally involved in a study at CU, and they used a product that our company has to give to older people. And as you get, okay, so here's what happens in a cell. You get oxidative damage and some other damage. Okay? That isn't functioning efficiently. So your body is programmed that it will form a little lysosome vacuole, and it will go get that mitochondria or get that Golgi or get some part, or some just proteins that are amiss in the body. It will degrade them, and then it'll recycle them. Break them down. It'll either kick them out of the cell, or it'll just break them down into, like we eat meat. You know, it doesn't become protein, it becomes amino acids, and then we assimilate that and use it and rebuild it. As you get older, autophagy slows down. And so when you go and you look at the cells, there's more damaged organelles within the cell itself, and the cell on the outside will be damaged because it hasn't been able to replace itself as fast. So it's kind of an equilibrium issue. Just like here, as you get older with this oxidative stress, the same thing is happening at a cellular level to proteins, to DNA, to other things too, this autophagy. NRF2 helps to stimulate that and speed it up. We're looking for other things too. The product that I have supposedly does that too. But, so the point being is it helps just about everything that goes in our body that goes on as we age. All the things that are killing us slowly, insidiously. There is not one. Except Protandim. Any other questions? So, where do you want to stop it? In the bud. You want to nip it in the bud. Nip it in the bud.
Not so.
Not 1 to 1, 1 and 2.
Well, I just didn't want you guys to show off, you know.
So I'd like to thank Alan very much for coming in and going over the science with us. That was deep too. Thank you. Got a lot of good notes.